Alright, so we'll finally work some probability into our classification problem. So first let me show you what I have here. I have it's the same story, right? I've got the red points and the blue points. So these are the individuals that belong to the red category, which we've been calling the positive category. And these are the individuals that belong to the blue category, which we've been calling the negative category. I've moved the positive or the red category over to the right here. It'll just work out a little bit better. And then also I've now given them a definite y-coordinate. So the blue points have a y-coordinate of 0 and the red points have a y-coordinate of 1. So this is the 0 category now. This is the 1 category. All right. And then along the x-axis, what I have are the score of some test that an individual would have. So for instance, this individual right here, they got a score of about 8 on this test. And they are from the red category. This individual from the red category got a negative score. And what I want to do is I want to estimate the chance or the likelihood of, given a particular test score, what's the likelihood that that person is in the red category? So down here, if someone gets a negative 8, chances are not good that they're in the red category. But if someone gets a 4, chances are pretty good that they're in the red category. So that's what I want to do. And from the last video, we've got 3 ways to do that. We could use log odds, or probability. And what I want to eventually get to is probability, but we're going to work backwards from log odds. So that's what I'm doing here in the first plot. I am trying to estimate the log odds that someone is in the red category, given that they have a particular score. And the only thing I know about the log odds is that it goes off to positive infinity and goes off to negative infinity here. Okay, and so what could it look like? There's lots of possibilities. There's lots of possibilities what this log odds function could look like. But it could be linear, and in logistic regression, that's what the assumption is, that when you plot log odds against the test scores, that it's a linear function. And so I have the sliders here which allows us to move it around, move the intercept around, and move the slope around, and so forth. And we also have the equation then of this straight line, which represents the log odds. But we want to start working back to probability because that's a little bit easier to understand. So the next step then we would want to go from log odds to odds. So this is a logarithm, right? If you want to go backwards, right? So when you have the odds, you get the log odds by taking the logarithm. If you want to go in the opposite direction, then you use the exponential function here. So if this is the log odds, then this right here, just e to that, would be the odds. And so we have this here, okay? And that makes sense because we know that odds, that goes off to infinity quite quickly, and it's close to 0 right down here. Let me also show you that the sliders here are connected to all of my plots. I've got one more underneath here, but if they are out of the way for you, you can move them down. So when you highlight a cell like this, that you see the 3 dots and there's the hand that comes over top, you can actually just move that cell down and use the sliders there. That's one really great thing about observable notebooks, and there's many great things about them, but that's one. So I can just use the sliders here and see what the effect is on the odds function there. Okay, but what we really want to do is we want to go to probability. So the odds, right? If you remember, it was the ratio of the probability to what's left of the probability, right? So let's say the probability is p. P over 1 minus p, then, would be the odds. If you think back, you have the red segment, which represents p, the probability, and the blue segment, which represents 1 minus p, the rest of the probability. So you could, do a little algebra and solve for p here, and this is what you would get. And so now we have an equation for the probability. So we have a plot here that represents the probability that someone is in the red category given that they get a particular score. And we can bring the sliders down again to see how things work. And you can see now it's a little easier to see that we're trying to fit this new curve, right? And this is called a sigmoid function. That's why that's the title there, because it has an S shape. And you can see we're trying to fit this sigmoid function to the points that we have. So how do you do that? Well, I'll talk about that in the next video. How is it that we will measure the distance now between all these different possible sigmoid functions that represent these probabilities and the points that we're looking at? So that'll be the next topic. But I just wanted to give you some idea about where this comes from. So in logistic regression, you've got your sample of points, and you're trying to fit a sigmoid curve. Instead of a straight line, right? Regular linear regression, it's a straight line. You're trying to fit a straight line to the points. Here, it's this S-shaped curve. But where does that come from? It comes from the log odds, and assuming that that is linear. Okay? So that's the relationship between logistic regression and just regular old linear regression. Okay, I think that's it. And so again, we'll talk about then how we can measure how close these points are to this curve next.